In this session, we'll show how to create the typical underground mine map for a room and pillar coal mine with Carlson software. We'll review the workflow procedures in general, assuming that you have the information for the mine offsets, which is the location of the ribs in the coal mine offset from the center line, and the as mined coal and rock thickness measurements known as the coal sections. We will draw the projection lines using advanced projections, set up the mine note defaults, use the mine notes auto left right to post the offsets, save the offsets in an ASCII text file, draw them from an ASCII text file to show what would happen if you had lost that information. Use AutoConnect to draw the mine pillars, draw the perimeter along the outside of the panel with that function, build the section configuration file, place the coal sections, we'll draw property boundaries and tag them, and we'll calculate the end of the month tonnage using quantity by average and quantity by grid methods. First, we'll draw the projection lines with the advanced projections. To do this, we'll go to the Works menu, we'll go to Advanced Projections. At the prompt, we see it says pick start point for the belt. I'll pick right here. Pick the end point for the belt up here. I'll indicate 3 entries to the left of the belt and 3 to the right. And in this example, I'm just going to accept the defaults, and I'm not going to draw any ventilation controls at this point, so I'll just put cancel. This gives me the Lineworks layout for a 60 by 60 foot entry, and at this point we will set up the mine note defaults. Going to the notes, we're in the underground mining module, and these are also in the basic mine module as well. Notes and works drop down is where we'll be. If we go down to the mine note defaults, we will create the ASCII text file during the mine node entry. The pillars will be drawn in the pillars layer. The perim layer will be used for the mine perimeter, and accept that. And now we'll use the mine notes auto left and right, and we're prompted for the ASCII text file that we will create. So I'll put this in as training, and I'm going to create a new file, so I'm not going to append it. The prompt is for tabular format, and I'll accept that by just hitting enter. And now we're prompted from station point, a node on, and I'm going to set the snap, in this case, to the intersection, and indicate the direction. I'm in ortho mode. I'm just going to pick up here for the direction. I could type in the azimuth that I wanted to lay out this projection on. The entry number will be 1. And now we're prompted for the distance from the station on the center line, which means from the point that we start, how far up the center line do we want to go, and I'll go 10 units, 10 feet. And then enter the left offset, which I'll also use as 10 feet, and then the right for 10 feet. And we'll see there's a point here and a point here known as an offset. And if we advance these up a little bit, If we go up 50 feet, and then over 10, and over 10 more, up 70 feet, over 10, and over 10 more, up 110, up to 130, and you get the idea. I'll pause this and add a few more entries, but so that you can see the process of moving to the next entry, I'll go ahead and hit enter. And if I ask for another SPAD, I respond with yes. Then we just repeat the process, starting from here, indicating the direction. Entry number will be 2, and then the process continues. At this point, I hit enter, do another SPAD. To finish up, I'll say no. Now, here's where you get a chance to save the offset file. Actually, the question is to print. I'm not going to print. We've already specified it when we started. And at this point, if something happened, we would be able to recreate these points, so that if I had gone up to edit, erase by layer, and I picked this layer right here and they all went away, it's in the layers offsets, they would be gone. At this point, I can come back in under the notes, offsets from ASCII file, indicate the training file, open that up, and they'll all be restored, so that if you create the ASCII text file, you have the opportunity to redraw those. The next thing we'll do is use the Auto Connect under Works, Auto Connect Pillars right here, and the prompt says select pillar points and projection lines. So we're only going to use the internal points that would create the pillars in our selection set. So we'll pick these, and we'll pick these points basically like that, and then hit enter, and that will draw all of the internal pillars. And now to draw the perimeter, we'll go into Works and use the Draw Perimeter option here. Now the only reason for using this, we could just draw a polyline in the perim layer, but this sets the layer for us and sets the snaps to node. So now it just allows us to very quickly drop onto the, and I'm in the ortho mode, so I probably would normally take that off for this type of operation, and then just go ahead and snap over to the nodes as they present themselves in order. Now, because I'm going to calculate volume in here, I'm going to hit C for close and hit enter, and then that will provide a closed boundary on the perim layer and layer of closed polygons on the pillars layer. And at this point, I'll go ahead and isolate to those two layers. It's not absolutely a requirement, but it'll help keep things very clear. So if I isolate to the pillars and the perim layer, that'll give you an indication of what we've drawn in terms of the mind map. The reason for showing you this area here is, if this is the whole idea of drawing the offsets, is to as you advance down the center line, if these entries get off in any way, you're able to document exactly where the rib lines are. The next thing we'll do will be to build the section configuration file, and that's found under the Works drop down under Configure Section Information. And what we're going to do in this case is, I'll just call it training. We're going to build a series of prompts that allow us to enter the coal sections or the thickness measurements of the rock and the coal as the surveyors would identify them in the mines. And since we're going to build a report at the end of this that indicates how many tons were mined in a specific period in this mine, some of the prompts we're going to enter at this point will help build that report, such as the mine name. And I'll call this the training-1. And we'll enter the abbreviated strata name, and since we're starting at the very top of what we would expect to see in a mine, the first layer I'll put in will be R, and indicate that that's going to be roof, in case any out-of-seam dilution was taken in the roof. And we would expect to see in this case maybe coal next, so I'll put a C in there and describe it as coal. And if there's an internal parting, I'll identify it as such. And if we came back under the parting and found another coal seam, we'd enter that. Notice in this prompt that it didn't ask for the full strata name because we've already identified C as the full strata name over the parting. If we have a floor material to be picked up, then we would give that a full strata name. If that defines the full expected geologic column, then we'll hit enter. And now we can enter individual densities. So you just type in an I, and then you'll be prompted for the density of the roof. If we're working in the English system here, so it'd be 155 pounds per cubic foot. If you were in the metric system, it would be kilograms per cubic meter. For coal, we'd see roughly 80 pounds. For parting, it could be anything. I'll put in 145. And for the floor, I'll put in 160. Then you're prompted to circle the coal section, yes or no. Normally, I don't circle that. And then you're prompted to plot the numeric value only, and I usually don't. I usually plot the abbreviated descriptions with it. And the text size of 6 in English is not a bad size for display. And you have a choice here to enter your measurements in inches or feet. Generally speaking, if the coal seam is 6 to 7 feet or less, you'd probably measure it in inches. And sometimes when it's thicker than that, you might enter it directly in feet. This example, I'll use inches. If I were going to use quantities by center line, I would post an entry width at each offset or at each coal section, but I'm not going to do that in this case. So that configures the section configuration file. Now we're ready to place the coal sections. So at this point, we'll go under the Works, Place Coal section. First thing it'll do is it'll prompt you for the section configuration file that we just created, which is known by the abbreviation SC. And we'll pick a sample point here along this rib. and a start point for the text, and then we'll slide on over to indicate the direction of the text. And then we'll start populating. Typically you'd have field notes at this point to go from. So if we said 3 inches for the roof, 24 inches for the upper split of the coal, 6 inches for the parting, 24 inches for the lower split, and 3 inches for the floor. That might be a typical example. We'll do another one, and so we just hit enter for yes, and we'll pick over here, and start point for the text we'll set out next to it, and then we'll draw the text in that direction. So then again we'll come through with so much for the roof, 21 for the upper split, 1 for the parting, 23 for the lower, 12 for the floor, and we'll do another one, and we'll come over this side, pick here, and we'll set the text just to the outside, and we'll say there's 6 inches of roof, 30 inches of coal, 3 inches of parting, 25 inches of coal, and 2 inches of floor. And then we'll pick one up here, and we'll populate this with a 5 in the roof, 23 in the coal, 3 in the parting, 32 in the coal, and 4 in the floor. And when I'm done with that, just hit end for no. Now, so that we can see this a little easier, I will try to change the color on these objects. The default color for these is cyan, but they get a little hard to see. And now you can see the actual numbers. And now we'll show you how these measurements and offsets and based on your spads are all tied together to calculate volumes of material mined. There is one other piece of this that is part of the process, and that has to do with identifying property boundaries for ownership. Should you cross a property boundary during this period of mining, and if you have a royalty that has to be paid to different mineral owners, then you'll have to split this analysis based on property owner. So if I come over to any layer here, I have to unfreeze the 0 if I'm going to use it, and then if I draw a couple of polylines representing property boundaries, hit C to close. Here. So we'll go to property, assign property boundary, pick here, hit enter, and we'll give it the name of the owner. The tract will be 1, 2, 3. Then just hitting the enter key will allow me to start the prompt over again. Hit enter. This will be belonging to Mr. Jones. This tract ID will be ABC. So now that we have the offsets that have defined the pillars and the outside of the mining area, and we've located and taken thickness measurements for the coal sections and placed property boundaries, we're ready to calculate the tons that were mined in this area. In order to do that, we'll go to Works, we'll go to Quantities by Average. We have three ways of doing this: Quantities by Average, Quantities by Grid, and Quantities by Centerline. The Quantities by Average is an arithmetic average of all the measurements. Quantities by Grid actually builds a little 10-foot by 10-foot grid across the area and calculates the volumes, and then cuts the volumes with the line work of the pillars and the perimeter to calculate the tons. Quantities by Centerline requires that you leave the projection lines in and that you take areas at each coal section, and it will average the areas and then multiply times the sum of the projection lines of the center lines. In this method, we're going to use Quantities by Average, and it will prompt us for the section configuration file that we just set up. And as part of our report, we can set the beginning date, and we'll set this for the 1st of this month, and then finish on the end of this month. And we'll use the standard reporting method, and we will select the property boundaries. Hit OK. We'll select the property boundaries by just doing a crossing selection across the two boundaries, and hit Enter. Next, we'll be prompted for the section name, and this is going to be considered on the advance. There are no pillar cuts in here. We'll set the recovery for the clean coal at 100%. And it asks us at the prompt what type of selection, and this is going to be standard because it's advanced mining. Hit Enter. We're prompted to select the pillars, the perimeters, and the section sample points, which would be this information right here. We'll hit Enter. You'll notice that it hatched the working area for one property owner and then prompted us to pick a location to draw the results. If we pick here and we indicate the direction of text here, we will see a report that shows the total area of the boundary, the pillar area, and the net area. Well, actually the total area is around the perimeter, and then the pillar area, and then the net area is the shaded area. Then notice it goes ahead and shades the other side and prompts us to pick the location and put the information over here. Once we've done this, we can repeat this process and do another area and have it append to the report. But if we're satisfied this is the only area we're going to do, at the another area prompt, we'll just hit Enter for no. And now we see the file that's created, the report that's created, that gives us a report for this training number 1 mine. That was mining took place the 1st of May to the last, and this first area owned by Mr. Smith on track 123. You can see the gross area mined in square feet and acres. The gross area mined in feet, area of the pillars, and net area mined, the depleted acres of pillars, and net area mined in acres. We've got the average for each of the different types of units that we were measuring: the roof, the coal, the parting, and the floor, in both inches and feet. Some to give us a total mining height. You can see the density assumptions in pounds per cubic feet that we made for each of those. And here you can see the report out of tons for each of those splits that were identified. And the program then goes ahead using the density of the rock, density of the coal, weight of each, and calculates an estimated percent yield. One measurement in here that's very interesting is the cavity acre feet. This number represents the volume of the void that's been excavated. So if it were ever filled with water and you had to pump it out, that is the volume of water that would come out of that area. for that property owner. When it's added together with the property owner for Mr. Jones, the same report continues on down until you get to the total for both areas. And then this cavity acre footage down here would represent the total area mined. Then here's the sum of the tons of the coal and the rock and the expected yield for both. Now, the way this is often reported, you can save this as an ASCII text file. You could print it out in different formats had we set it up to print the different formats. One of the ways I've seen this done across the industry is to print this to the screen by left picking here, and then we can set the type of text, M text or regular text, and set the height for this report, put it in any layer that we'd like. And if I select this layer, this is in black so I don't have to change it. If I hit OK, then zoom out a little bit and pick a start point and rotation angle, and if I close out of here, then I'll see this report, and I can move this underneath of this, and basically the report is right in the drawing with the drawing itself. And I've seen people print this out to create a page that represents this report for the end of the month tonnage. That was quantities by average. Next, we'll do the quantities by grid, which is very similar in its approach. The only thing I'll do here is erase the hatch for each and repeat the process. So if I go to Works, Quantities by Grid, I'll use the same and I've got to get back to the same file that we were using. Oh, this is an MPD file, excuse me, it's prompting us for. Since we didn't have an MPD file for this, I'll just give it a training. Sometimes certain things you do, if you haven't created a mining project file, we'll request that. Then we can go with our section configuration file. We can use the same setup that we had before. Pick the property boundaries, and those would be here. We have the same prompting that it recalls that we did for the quantities by grid. Now it says select the pillars, perimeters, and at least 3 coal section points. So we'll pick that information right there. We don't have another area, so we'll hit no. It comes right back to us with a report. And we can do the same thing that we did with the first report, printing it to the screen. It recalls our previous settings. And now if I put that right here, hit enter. And if we compare the numbers, we'll see that the quantities by average coal tonnage was 3,501, and the quantities by grid was 3,514. So the agreement between the two methods is very good. Thank you.